So welcome to lesson number 7 in our geometry series. And this lesson is specifically over a special right triangle known as the 45, 45, 90 right triangle. 45, 45, 90 right triangle means you have a right triangle that has two angles in it that are exactly 45 degrees. These two angles are 45, and obviously the other one is our 90. And we have a right triangle, and that's how you know the others are 90. So in a 45, 45 degree right triangle, we have this situation here. This is also known as an isosceles right triangle. If you remember, an isosceles triangle is when the legs are the same. And you learned about these as in the beginning of middle school, and maybe we called them a tent or a traffic cone. That was your isosceles. And what it means is these sides are equal. That's your isosceles right triangle. But when we turn this angle here into a right angle and we flip it over onto its side, that's when we get this picture here. So we took that isosceles triangle, or that tent or traffic cone that you learned about, and we kind of widened the legs out on it just a little bit. So we took this leg out in this direction, and we took this leg out in this direction, and it increased this angle to 90 degrees because this got bigger this way when that leg went out, and this got bigger this way when that leg went out. So we kind of spread those bases, extended this base a little bit and made it longer when we spread out that top angle. Okay? That's how we got this 45, 45, 90 right triangles. It's no different than the isosceles triangle that you learned about in pre-algebra, 6th grade, 7th grade, all of those classes where you learned about this isosceles. We've just tipped it over a little bit and changed the size of it. Those off my screen. I don't want them to distract. Now, what you're going to learn about the 45, 45, 90 right triangle is as you shrink it or enlarge it, the legs and the hypotenuse always stay in the same ratio. So a little bit about ratios. You did this in 6th, 7th, and 8th grade pre-algebra. You also did it in Algebra 1. Let's say we had 2/3. And we want an equivalent ratio to 2/3. Well, that could be 4/6. That could also be 20/30. It might even be 14/21 if we increase by a scale factor of 7. Every single one of these ratios are equivalent. They're equivalent fractions or equivalent ratios. That is the concept that we're going to take into these right triangles. So as we increase the size and enlarge this triangle, the length of the hypotenuse and the legs of the triangle are always in the same proportion. They get bigger or smaller at the same rate. That ratio is always this. So if the legs are a length of 1, the hypotenuse is 1 times the square root of 2. If your side lengths are 2, then your hypotenuse is 2 times the square root of 2. If your side lengths are 15 and 15, then your hypotenuse is also 15 times the square root of 2. Okay? So if you know a leg, here's some rules for you. If you know the length of the legs, they're both the same. So if you know one, you know both. Then multiply times root 2 to get the hypotenuse. If you know the length of the hypotenuse, then do the opposite. Divide by root 2 to get the measurement of one of the legs, which is also both, since it's an isosceles right triangle, they are the same. So let's go back to this concept that you've learned just in math over the years. If something gets bigger, did it multiply or did you divide? Which one of these is the longest side? That's your longest. Your hypotenuse is always the longest. Your legs are your short ones. So if we're going from the leg to the hypotenuse, it got bigger. So if you're converting the leg to the hypotenuse, it gets bigger, so you multiply. If you are going from the hypotenuse to the leg, you start with the hypotenuse and you convert it to the leg, it gets smaller, so we're going to divide. Okay? Just think about that as you do these problems. If you're getting shorter, you have to divide. If you're getting longer, you have to multiply. And let's work some examples of 45, 45, 90 right triangle. So if we have, whoops, bring our rule over here. You have these measurements. You know, I'm actually going to just move this whole triangle up. That was a little more difficult than I thought it was going to be. I apologize. Like moving a house. Oh my goodness. There we go. I have recreated that right triangle a little bit higher up on the screen. So give me the ability to do some work down here. So we're going to give this some side length of x, y, start a little bit easier. Let's say this is 10 and 10, and we need to find the hypotenuse. We have 10 and 10, and we need to find hypotenuse, so we're going to make the hypotenuse be x. Well, obviously, that is just 10 times the square root of 2 in that one. 10 root 2. Easy peasy on that one. Whoops, today. Oh my gosh. 10 root 2. The mouse on my computer is slippery. There we go. Got it. Now let's go backwards. Let's put some orange measurements in. And let's say all we know is 25 for our hypotenuse. And what we need is the short leg. And again, whatever this is also. So you find one leg, you know them both. So this is also our y up here. Look at rule number 2. If you know the length of the hypotenuse, then divide by root 2 to get the length of one of the legs. So y equals 25 divided by root 2. So we're going to have to put that into our calculator and figure that one out, because you cannot leave. Here's another rule for you. You can't leave a root symbol in your denominator. Ever. Not simplest form. You can't do that. This cannot be our answer. You will not see it as one of your choices. Although you might see it on your study island as a choice, because they like to give you different options of things just so that you know. But you will not see it in real life ever. Okay? All right. So let's look at our calculator, and let's figure out what 25 divided by root 2 is. So we'll clear everything off of here. And we're going to say n over d, 25, directional pad to the bottom. Just put that root 2 in. So second, square root 2, directional pad to the right, you'll be out of the fraction, enter. So there's that converted. 25 root 2 over 2, and if you need it as a decimal, you can switch it. If your instructions tell you to estimate or to round to the nearest hundredth, there's your answer, 17.68. So that actually is, in simplest form, exactly 25 root 2 over 2. That was a pretty good one. Got a fraction line in there. And it's approximately, because we estimated, so we have our curly equal sign now, it is approximately 17.68 to the nearest hundredth, whatever your problem asks for. Okay, so let's do some that are just a little more complicated. And let's look at number 1 on your worksheet. And on number 1, we're given 9 root 2 over 2 as one of the legs. So 9 root 2 over 2. We're going to do this one in blue. 9 root 2 over 2. And what we're looking for is our hypotenuse and our other leg. They're asking you to find both. Well, the other leg is the same. So we already know that x is the exact same thing as this. So you can rule out some answer choices pretty quick because 9 root 2 over 2 is your x. However, we don't have that as any of the, I'm sorry, I've drawn that backward. Whoop, 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 whoop. My mistake, I mislabeled the x and the y. What they have is x is your hypotenuse. They turned the picture around on me. And y is your leg. So y is 9 root 2 over 2. You can already know that because your two legs are the exact same size in a 45, 45, 90 right triangle. Y is 9 root 2 over 2. So it could either be letter B or letter D. Definitely not A or C. We know this because it's a 45, 45, 90 right triangle. So we need to figure out the hypotenuse. So we have a leg, and we're going to the hypotenuse, so the length is getting bigger. We know the leg, and we're going to get the hypotenuse, so we multiply by root 2. So we're going to have 9 root 2 over 2 times root 2. On your calculator, you're going to input 9 root 2 over 2. So we need a fraction. N over D. On the top, it's 9 times second x squared. 9 times root 2, so put your 2 under there. All of that is over, so down button, 2. 9 root 2 over 2, get out of the fraction by directional pad to the right, times, so we have to multiply that measurement of that leg, root 2, so second x squared 2. That is the exact order of your keystrokes to put this in your calculator. You have got to practice that. So 9 root 2 over 2 was the length of one of your legs, so we're going to multiply times root 2 to get the hypotenuse. Enter. 9. It's hard to believe that all of that came up to be 9. So the length of your hypotenuse is 9. Therefore, x equals 9, right there. Final answer, B. Okay? So on number 2, we actually have the hypotenuse, and we need to find a leg. So on number 2, we have hypotenuse equals 5 root 2 over 2. And we need to find the measurement of A and B, which are legs. So that is going to be the second one. We have the long measurement. We have to find the smaller one. Get smaller than when you divide. So we're going to divide the length of the hypotenuse in number 2 by root 2. So in number 2, our hypotenuse length, if you just open your worksheet, you'll see it, is 5 root 2 over 2. There's a fraction. 5 second root 2. Directional pad down over 2. Directional pad to the right. 5 root 2 over 2 divided by second root 2, enter. So 5 over 2 is the length of your short leg. A and B are the same because it's a 45, 45, 90 right triangle. So your correct answer is C on number 2. This worksheet is only practicing the 45, 45, 90 right triangle properties. Do not forget, as always, upload a picture of your notes. on number 1. Upload pictures of your work shown. Don't print the worksheet. Write things out on paper. Draw your pictures. Label them. All of that stuff. You need to show all your work. And then input your multiple choice answers into the form. My goodness. Okay. I'll see you guys in the next lesson. Have a great day.